In today's video, we are looking to build an interesting project which is a BSC sniper trading bot for newly created 4 meme tokens. For that, we are going to use the Bitquery Protobuf Kafka stream to get the newly created 4 meme tokens. Then we are going to implement the buy and sell functions with the ethers.js library. And also we are going to see how we can deploy this bot script on a cloud service like Google or AWS. So now let's just understand the logic. So these are a bunch of imports. The load proto is an npm package created by Bitquery so that you won't have to manually install and update the protobuf files. And these are the imported functions from this execute trade.js file, which will help us execute our trade. We'll see the logic of those further in the video. Now we are defining some constants, which are the Kafka username, the Kafka password, the topic which we are subscribing to, and the ID, which is a random hexadecimal value, which would be joined in our group ID. So the username and the password are stored in the .env file, which I'm of course not exposing now. And the topic for this tutorial is bsc.tokens.proto. It is basically a stream that would let you subscribe to the token transfers taking place on BSC network. Now we are defining our Kafka object using the Kafka JS library. Then over here we are defining our consumer, which is a Kafka.consumer instance with the group ID as username hyphen the ID, which was this random hexadecimal value. This is done so that for a same set of credentials, no two user have a clashing group ID. Now there is a little helper function over here, which is convert byte function. So the protobuf message are generally base 58 encoded. So to get a readable value out of a buffer that is returned in the protobuf messages, we are using this function. Now coming to our main function run. So we are defining this variable as ID block message. You can define it to whatever you want as the await load proto for the topic. So this load proto is basically a function which would get you the respective protobuf file and the protobuf message schema for a particular topic. Now we'll connect the consumer, we'll subscribe to the topic, and we'll set the from beginning to false since we are looking to get the newly created tokens with minimal latency. And we have also defined a scene token set. This was defined because one token might appear more than once, and we don't want to trade a particular token more than once. So we are defining a scene token set to keep a track of the tokens that are already traded. Now we are going to run the consumer, and for each message, we are getting a buffer, which is message.value. Then we are going to decode it and convert it to an object. Then we'll get transfers, which is the message object dot transfers, and we are going to iterate the transfers, and for each transfer we are getting the particular fields. So these two conditions together implies that a new forming token is created, and if the token is not present in the set, that is the token is not already traded, then first we'll add this token to the set. Then we'll buy the token using the buy while launchpad function. Then if by receipt, that is if the token is purchased, then I'll set a timeout for 1 minute. And after 1 minute, I'll sell the particular token. And finally, in the main script, we are calling the run function. Let's jump into our helper functions, the functions which are helping us to actually execute trade. So mainly we are using the ethers library. These are the imports we are using. So now we are defining our constants. So then let's discuss about the other constants we have defined. We have defined the launchpad address as ethers.get address, the particular address. This was, as mentioned earlier, the phone index exchange address. Other than the launchpad address constants, we have other constants that are buy ABI, sell ABI, ERC20 underscore ABI. Yeah, these are some constants which basically tells what kind of functions are present in the contract. Now we are initializing two contracts. One is a buy contract, one is a sell contract. So now let's discuss our two most important functions. The first one is buy by launchpad. So you can see token address is a parameter, amount BNB. If not given explicitly, it's 0.001 BNB. The main amount is something that helps us with the slippage. So firstly in our function, we are calling another function and awaiting for its response. The function is init nonce, which initiates a nonce for transactions. Then we are trying to get the funds as sparse ether amount BNB. Then we are defining the data parameter. Then we are creating a transaction request to the launchpad address with the following data, the value as the funds and the gas limit as this number. Then we'll get the recipient as the send transaction with nonce, passing the transaction request value and return the receipt. Now let's try to understand this send transaction with nonce function. So the main point of this function is to send a transaction with explicit nonce and handle errors that could come from gas research or anything like that. So basically we get a transaction request and we have defined the max retries as 3 by default. So if the type of next nonce, which is the variable that we have defined earlier over here, is undefined, then we'll wait for some time for around 500 milliseconds. And once the next nonce is defined, then we'll have our attempt starting from 0 all the way to 3. The transaction request.nonce is set to the number next nonce. And if there is no transaction request gas price, then we'll define that over here. Then we'll have our transaction response as the wallet.send transaction with the parameter passed as transaction request. So this is the line where the transaction is actually executed. We'll update the next nonce and we'll return the awaited transaction response. Also, if message includes replacement enterprise, this kind of error. And if the attempt is less than the max retries, so we'll try to update the nonce of the transaction and then kind of retry it again. So with that understanding, now let's try to understand the send token while launchpad function. Here we are just passing token address as a parameter because we are looking to sell all the tokens that we have purchased earlier with this. So again, we'll initialize nonce, then we'll have our token contract as the ethers.contract, the token address, the ERC20 API, and the wallet. The main reason for this is firstly, we'll need to get the balance of the token using token at contract.balance. So if the balance is 0, then we'll just console.log this statement, return null. But if it's not, then we'll try to approve the tokens held by our wallet. So what we are trying to do is basically approving this launch address to sell the tokens that we hold in our wallet on our behalf. So for that, we firstly need to approve this address for that. Once that is done, we'll send a transaction with nonce to the token address with the data as the approved data, the gas limit as the 100,000, and basically this will create a transaction to approve the data. Then once it's approved, we'll try to sell with the sell data as the following. Then we'll have a transaction request to launchpad address with data as sell data and the gas limit, which is same to the one in the buy by launchpad function, 300,000. We'll have a recipient with send transaction with nonce, passing transaction request. Then once that's done, we'll console.log this message, return the recipient. If it's not, then we'll console.log error and return none. So that was that for explaining the logic. Now we can run this script using npm run start. If you have defined this script in the script section under package.json, otherwise you can just use node index.js. I'll hit the npm run start and you can basically kind of have this bot run locally on your PC. But one major issue is that with Sniper bots, we are talking about latency, how fast we can get a newly created token. So currently, my device is in India, but the issue is that the Bitquery Kafka servers are based in Finland. So this would cause a pretty huge lag.
So what you can do is you can create a virtual machine on any cloud service provider, AWS, Google Cloud, Azure of your choice. Then have that virtual machine instance location set to the EU North one. Mostly that's the code for the virtual machine to be in Finland. And get the and once you basically created that instance, you can SSH login into that instance from the cloud shell itself or whatever option is provided. Then you need to install some basic dependencies like the git, the node, the npm. You could just create a repository for the same project, then clone that in that virtual machine, open that directory, and run the npm run start command over there. And even better, if you are looking to run it 24/7 continuously, there's another command goes by the name pm2, which would look something like this. Just make sure to install the pm2 using npm install, or in that case, sudo npm install. Now I'll show you a clip where I'm running this script on a virtual machine instance on AWS.
As you can see, the purchase transaction is already mined. In around 1 minute, the sell transaction and approved transaction would also appear. I'll fast forward this part for convenience. Now you can see the n number of tokens, the total number of tokens are approved, and now we are trying to sell those tokens, and the sell transaction is finally mined. Now, if you're looking to build something familiar where you would require some low latency solution like the Bitquery Protobuf Kafka streams, then you could get the access to or credentials to the stream by contacting our sales team. I'll share the contact details in the video description. Thanks for watching, like, share, and subscribe, and make sure to join the Telegram channel from the description of video for any doubts. I'll be sharing the link to the official tutorial from docs and the complete code base in this video description as well.